we had 220 paper submissions to this event. And I wanted as many people to be part of this event as possible. So we have great speakers with great backgrounds, and I just had to pick. It was like, I couldn't lose. But what we're gonna do now is, they're called Ignite Talks. We call them Ignite Talks. Typically the format is you get 20 slides and 5 minutes to get across an idea. We are not gonna be that rigid with that. What I wanna do is, I wanna get at people who have different perspectives to get their ideas across. And if it goes 6 minutes, we got some surprise guests at the end that is not on here, who are very fortunate to have join us. And I want to make sure that we have different perspectives. So first we have Will, and Will is going to talk about AI-assisted grant and RFP writing workflows and how to scale funding without scaling costs. So I met Will a couple times. He's a good guy. He's doing some great work. So I'm going to let him take it away.
Thank you. Thank you. Thank you, everyone. I'm really happy to be here. Thanks, Mark and Todd, for organizing this. I am one of the co-founders of I-90. We are a minority-owned business consultancy here in the Triangle. And the work that we do at high level, we do facilitation, we do training, and we do technology. I'm a techie at heart. And part of the work that we realize with our clients is that there are very specific situations as they think about their strategy 3 years, 5 years, that could be augmented by AI. And I want to share with you in 5 minutes one of those use cases. We're working with a nonprofit in Chatham County, the Hispanic Liaison. And as you know, there's a lot of challenges that nonprofits are facing now with their funding. And we are deploying a very small, very targeted use case to help them out with that. So the way that I-90 works is that we will partner with our clients and think through which are the areas where we'll create the most impact and that you could reduce the challenges you're having, either through automation or in this case through AI. These are the 4 areas that for this client particularly will be very beneficial. I think we can extrapolate in general and think for a lot of nonprofits and for a lot of small businesses, identifying opportunities and really highlighting which are the ones that are best for us. It's one of them. The actual process of writing the draft and getting that with the appropriate language and getting it with the correct terminology and hitting all the parts that the donor is looking for is also important. The revision of that pre-submission and of course that feedback loop of what is good and what it isn't. The part that we, through our practice, realize is that some parts might be very critical and important, but you have to start solving mainly for the biggest pain points that you have and the ones that would create the least amount of work or training necessary to get started. When we started doing the initial work with AI, the models changed and things were a little bit different, so you have to be able to invest the least amount of time possible to be able to generate the most amount of work. So the way that we went about it with this client is to look at these 4 areas that they do need help with and choose which is the one that we can get implemented today that can get you moving and that can get your organization getting some funding and moving forward. So we decided to go for the writing part. It may not be the most critical, maybe for some folks thinking, how do I create my funnel and identify the opportunities is more important. But in terms of quick wins and how do we move forward faster, writing the grants and getting some applications out seemed very critical for them. So the initial work was not with AI yet. It was conversations and interviews with the client where we identified what were the categories that they were trying to apply for, which were the very specific grants that they were trying to go after, and then select previous applications. This part will be for you, if you were today earlier, and you saw what Mark did with training the tool and giving context and providing information. It was selecting the good quality input. So with our clients, it was selecting the grants that they won to start with, which are the big wins for you guys. Then the ones that had the language that you use for those type of applications that are relevant as examples. The ones that maybe have really good language, but you didn't win, but you still are very proud of the way you put together that application. And finally, the ones that you were not selected, but feedback was given, and you can learn from that. So we created all this repository of information with the client to categorize what is the right quality of information that we want to provide to ChatGPT. The work now that we did with ChatGPT was first to use the area of projects that you've seen to capture all that data and have ChatGPT learn what is the critical information, how does the organization talk about themselves, what are the metrics that they use, what are the results that they produce in a very structured way. The goal was to train the tool to mimic the writing style of the organization. By going through those successes, ChatGPT was able to reproduce close enough. This is not perfect. If we want to quantify it, let's say 60 to 80% quality of result in training the tool and replicate the language. The next part was training the tool to actually write the application itself and know which are the areas that, as a ChatGPT, I'm going to complete for the organization, and which are the areas that I'm going to prompt the grant writer to write the content and provide the necessary information so the document will be completed. Finally, was just creating the GPT itself, moving from project into GPT for two reasons. Prompt the user to upload the application, so ChatGPT could create a markdown document, create a format, and have it ready to be populated. Write the initial draft and key the grant writer into what is the input that I am not going to guess or estimate, but I need verbatim from you to be able to put it on the application and generate that first draft. So from a process that would typically take this organization about a week, executive directors, grant writers are really busy. They're trying to juggle multiple occupations, and that's what it will take. It turned into just an afternoon exercise. And they're currently using it, sending applications. We don't have the feedback yet in terms of win rate, but from sending one application a week, we're cutting down for them to have the 10 that they're focusing on. They sit down, executive director, grant writer, in an afternoon, and they get them all ready to go. And that's the exercise that our client is going through. So the lesson learned from this, what are the benefits and considerations as we think about using AI for a process like this? Speed, of course, much faster. Instead of trying to work remotely on coordinate times with your executives, you can actually have in a very short period of time go over the important part, which is reviewing the outcome and how good the application is, and give chance for rewriting. The language itself, being able more concise, the tool, it's able to pick up what the donor is looking for and the type of language that the foundation or the donor is expecting, so it's able to match it, especially with the latest models from ChatGPT. The quality of picking out the language of the donor with the language that the client wants to use is also very good. The two big considerations for us, it's the human part, the human experience, it's critical. We're not replacing anyone. We're giving the experts time to not have to type, write, research, find the good application they wrote last year to bring it forward. It actually does it for them really, really quickly, and there's consistency on the language. The tool also picks for which donor different language and tone is being used, depending on the type of applications that they're writing for. So that's clearly a benefit, but it's the constant reminder that the skills that these organizations have, that human factor, is even more critical now because they're not spending time typing, but actually assessing the quality of the application and making the necessary changes. And the other consideration that it takes a little bit of time in back and forth with the tool, it's maintaining the organizational voice. You don't want your application to be robotic. You don't want the application to sound like it's being written by ChatGPT. So that's the biggest challenge for a lot of these organizations because they have their own ethos, their own language, their own culture that they want to represent as they write these grants. It has taken them sometimes decades to fine-tune the way that they write. So the iterative part in being able to quickly produce the outcome, the draft, hand it over to the grant writer to provide feedback for the tool. What we're doing is we're capturing that feedback on the phone, and we have ChatGPT we talk to ChatGPT basically. It summarizes everything, and it's providing that loop to go back for the retraining. So there's also not much effort from the grant writer who's got a very limited time. If anyone here works in nonprofits, you guys know how expensive grant writers are and how much of a luxury is having their time to provide that feedback. So that part of gathering the voice, it's that loop in the feedback that we're able to capture. So in under a little 5 minutes, this is the use case, this is the example that we're trying to put together. Instead of adding another person to produce a role, instead of having to hire and train, what we're doing is elevating the quality of the work that the grant writer is doing. In this phase one is getting this application faster so the nonprofit can get some income coming in. And at a phase two, we're gonna go back to opportunity identification and start working with them on how do you train ChatGPT to identify the right grants, the ones that fit them, the ones that they have a higher win probability, create that funnel so the writing can also be much faster. So that is a phase two that is coming up with a client. But at this point, we're happy with the result. And it's been a very quick presentation. I hope this is useful to you guys. That's my contact information. That's my LinkedIn. I'll be here all day tomorrow if you want to go into details on how this happened. I'll be more than happy to chat with you all. Thank you.
I feel sort of silly because I'm talking about writing blog posts and Will is doing grants. My first job as an intern out of college was writing grants for the Pennsylvania Minority Business Development Authority. And what it was really interesting was once those people got those grants, they had a disproportionately high amount of success because without those grants, they wouldn't have been successful and they couldn't get capital the normal way. So as someone who used to sit with like an early version of, I think it was WordStar, it wasn't even like Microsoft Word, writing grants, not having any idea because a lot of those folks just didn't know what to do. That's a great use case, so thanks, Will. The next person that we have, I think Franzi couldn't make it today, so we're gonna go to Tia Pope from North Carolina A&T. A little bit of trivia. North Carolina A&T is the first undergrad program, has the first generative AI undergrad program in America, here in North Carolina. So I am going to, I'm terrible with this remote. It's gray, never mind. It's sitting right in front of me. It's been a long day.
No worries.
So we are going to start you up.
Thank you.
And let's do, all right, that big button. button is forward, the little one is back.
Awesome, thank you.
Thank you.
Thank you, everyone, for having me. I want to encourage you today to try to leverage pre-trained transformer models for protein structure or function prediction. I'm not a biochemist, but I do computationally study proteins. I'm a third-year PhD at North Carolina A&T, Aggie Pride. And for me, I generate novel protein sequences, but then I find new ways to evaluate them. My research has levered, or at least garnered, collaborations with Johnson & Johnson, Eli Lilly, and MIT Lincoln Lab. So one of the things that I've learned as a computationalist who does not have a background in biology is that there is a secret war going on. I call it protein wars. You have the good side and you have the sneaky / bad side. For those of you who do not know, we have antibodies, enzymes, hormones in our bodies to help us build different parts, repair, help us to fight off the bacteria and viruses that might enter, and just tell our bodies what to do. On the bad or sneaky side, we do have viral-based proteins that can come in and act as spies and trick our cells into letting them in. We do have rogue proteins that essentially allow diseases to form, and then we have misfolded proteins, which essentially can cause damage to different parts of our bodies. I would say that we've entered the twilight zone, for those of you who know, and we've experienced this with COVID-19 a handful of years ago when it shut the world down. It's not a protein, but it is a virus. It uses proteins in many different ways to help it shape, to assemble and release, to connect to the viral RNA genome, as well as attach to and enter human cells in many different ways. So AI has entered the chat, and one of the biggest advancements in the biochemistry space is AlphaFold. I believe we are now at AlphaFold 3. Essentially, it has streamlined the process of predicting a 3D structure of a protein sequence, something that could take months or even years to do, or a full dissertation to do. Now you can do it in a matter of hours or even minutes. Traditionally, it's an X-ray crystallography process that is usually in place. Then there are transformers, not necessarily these, but this one, the attention-based architecture. But before then, we had a neural network called Recurrent, and essentially it took in language, but one, let's say, segment or sequence or word at a time. So think like you're talking to a toddler and they're processing a word at a time versus talking to, say, like a high schooler or a college student. They can take a full body of text and understand that at once and communicate that back efficiently. So if you check out the paper, Attention is All You Need, you can find out more about that architecture. So the application of AI in the biospace, essentially it has dramatically changed how we, one, evaluate proteins, look at their function, et cetera. Experimentation has been streamed down, testing and drug development. We all saw that with the emergence of the COVID vaccines, something that typically takes 10 to 20 years to get through the door. For some, took less than a year. With that being said, one of the things that I, again, want to tickle your fancy about is just getting you interested in helping out in this space. So in terms of protein production, it is a natural biological process, but the thing is that we don't 100% understand all of their functions. And in fact, even the ones that are publicly available on the databases, they have not fully been experimentally validated. So we need researchers, we need people who are just curious to go out and help us do this computationally. With that being said, everybody is different. So we know that medications, food, our environment impacts us all differently. And so even though we might discover a protein, we may not know how it functions or reacts to different things. And because of that, there's more to study. There's a thing called dark proteins where we may know about it, but we may not know how it functions. And it's anticipated to be more superbugs like COVID-19 that comes to pass. And so we need those curious parties to help us to kind of figure out what these might be. With that being said, that help would help with essentially creating new drugs, creating new foods, creating new ways to basically help us to sustain our lifestyle here on the planet. In terms of two of the models that I want to bring to your attention, evolutionary scale modeling, which is more of an encoder-based transformer. It does have decoder-based properties, and what I mean by decoder is that it has the ability to generate. I believe that has been the fad here. GPT-2 is built on GPT-2. It's decoder-based, so it does generate new protein sequences. With that being said, the lift to use these tools is pretty straightforward. I think you may have heard of Hugging Face throughout the day. You can pretty much use this through the Python package, or again, get you a quick token from Hugging Face. Essentially, for GPT-2 to start generating sequences, all you need to do is provide it with a seed, so a string of amino acids, and then it essentially generate new amino acids to that sequence. Or you can unconditionally generate sequences, which is what my research is focused on, and just ask it to generate new sequences. You can then take that sequence, put it through ESM, and try to figure out, okay, what is the likelihood of it to function in X way? So if we think that it might be an enzyme, we can put it through ESM to kind of figure that out. You know, enzymes, they help with speeding up a lot of processes in the body. And so if you find out that something is so novel, does a certain function, then it can help you with, oh, okay, this could be harmful, or this could be used for medications, etc. Again, this is something that is used, or at least the pre-trained version is on Hugging Face. There are other use cases with ESM. You can compare it to other proteins, you can look at patterns and other functional properties. So I hope that has interested you enough for you to start getting curious about proteins and maybe even leveraging some of these models that are out there. As part of my research, I am building some, so if you do sign up, you can go ahead and send me a connection on LinkedIn. I do have some reference papers and content. And then if you want to play around with these with a low bar, feel free to sign up. Thank you. Thank you.
So Will just one-upped me with his use case, and Tia just dunked. So this is the kind of stuff that I think is the awesome use cases, other than creating excuse me, other than creating blog posts and some of our examples. So the next, we have a duo. This is interesting. Richard and Tony Shan are going to talk to us about practical generative AI. Is that right? That's what's on the paper. Am I right? Yep. Okay, cool, man. Is it just Richard, or is it Tony?
Just Richard. Tony couldn't make it today.
Okay, all right. Okay, I'm okay. Now we're gonna get a little geeky, and we're gonna talk about observability, and all right.
Woo! Thank you.
I like the energy.
Hi, everyone. Yep. I'm a student here in Durham, and I'm a generative AI researcher at the MITRE Corporation, and today I'm here to talk to you guys about generative AI observability. So my main goal in today's presentation is to impress upon you all the key relevance of generative AI observability. I'm sure a lot of you guys in your deployments or in your jobs have worked with these generative AI systems. However, observability has usually lagged behind the actual progress on developing generative AI writ large, meaning that we're having more and more generative AI systems with less and less observability to check back on it. So let's first talk about what generative AI observability is writ large. You've probably seen generative AI and a bunch of chatbots being deployed in all kinds of environments. If you go to any sales dealership website, or maybe like a car dealership, or even Amazon, there's probably some agentic or some small chatbot on the website that you can talk about. In that scenario, observability might not be the most important thing, since it's just telling a user where they can find a product or how to navigate to a page. But if we take a look at some more mission-critical examples, such as if we're using generative AI in things like healthcare, telling a surgeon what surgery to perform, or if we're using generative AI in something like finance predictions, those are two scenarios where accuracy and efficiency, i.e. the latency of the generative AI system, are very, very important. So that's where we need to implement an observability framework to better optimize these results and figure out how accurate and how latent your system is. So you might be asking yourselves, why have these products not already existed? Well, some of them have tried, but they all encounter a couple of key problems. The first is that their models are very, very complex, especially when working with generative AI models and natural language processing. It's very difficult to kind of get the behind-the-scenes parameters inside of these models and how these models are doing their probabilistic outputs. A lot of generative AI monitoring and observability frameworks struggle with doing this. Second is a lack of available data, especially if you're deploying your generative AI system to a user base that it's not been trained on. There's often a lack of good data or ground truth data for comparisons. And then, of course, when you're deploying into a new environment, there are always going to be a lot of problems that you can't predict with users or new edge cases in deployment that might come up with a lot of issues. So with these issues, you've probably seen a lot of papers online, whether it's from OpenAI or places like Anthropic, about their redlining teams where they find these places where sending a prompt into a chatbot can generate a potentially nefarious or malicious answer. And that's really problematic. Again, we're optimizing things like accuracy and things like efficiency, and that's where observability really has a key role. There are a couple of essential metrics that are key to observability. For the sake of this 5-minute presentation, I'll focus on the 3 key ones: output coherence, accuracy, and latency. If you've ever worked with machine learning or deep learning models before, you're probably familiar with the concept of coherence. You've probably worked with coherence in both the coherence of your input data and coherence of the testing, basically how logical and how correct and how much of the training or data actually makes sense. In the sense of generative AI models and observing them, the output coherence is how much the output is actually semantically relevant and is it logical following the data it's been trained on and following the query that we've queried this generative AI system with. The second is accuracy. Accuracy is actually really, really interesting because there's no real good industry metric to single-handedly evaluate the accuracy of a generative AI model. However, a lot of things have been made, things like frameworks like RAGAS or ARIES for retrieval augmented generation system evaluation, if you ever work with that, and they have these custom math formulas that they've made to evaluate whether or not an answer is correct given the query, the ground truth, and some of these other values. A lot of companies I know of are actually implementing their own custom evaluator models just to judge if their generative AI system is accurate or not. And lastly is latency, especially if you're deploying a generative AI model on the edge or something again like finance where you need to make split-second decisions that need to be correct. A lot of the time, latency is a really big issue on how fast can we get these decisions made. So like I said, there are a couple of generative AI tools that are already in existence. These are things like middleware and like Dynachunk. However, the problem with these systems is they don't take an LLM ops approach. A lot of these systems take a DevOps approach that is being applied to LLM operations. However, if you want a more LLM ops integrated approach, a lot of the time you're going to have to be building your own custom framework because you want to optimize for things like tracing and input data and a lot of these more LLM specific metrics. That's why I'm here to recommend frameworks that are not just DevOps frameworks applied to LLM ops. Rather, your companies should probably be looking to implement things like RAGAS or ARIES, which are both Python libraries that allow for dynamic optimization, which allow for dynamic evaluation of your generative AI frameworks. RAGAS, for example, I've worked with previously, and it's basically just a Python package you import, you feed it data from your ground truth, your context, and your actual LLM generated answer, and you're able to evaluate the efficacy, i.e. the accuracy of your language model. Like I talked about, there's no single one great metric to evaluate how a language model performs. That's why these very packages, such as RAGAS, have actually developed over 9 different metrics of their own. So that what that means is that each package, each company you work with, each language model deployment you work with is going to be a little bit different on how you're able to observe its accuracy, how you're able to observe its output coherence, and how you're able to observe its latency. A couple of key things arise from all these different tools that are already on the market. You can see some of them on the right-hand side of this slide. However, the key points is that you're able to have a dashboard where both technical developers and non-technical users alike are going to be able to understand what's happening behind this LLM, how it's performing, and how it's performing in the test cases that we need it to work well in. We also can see end-to-end performance analytics. That's things like, oh, how is the chunking doing in relation to controlling accuracy? And, oh, how is the embedding working? And when we actually generate, does changing the LLM behind the system actually have a big, big difference? So the key with observability is depending on whatever framework you work with, you need to be able to ensure that your framework is accessible to both technical people and non-technical people alike. And with that, you're able to optimize for the metrics that you care about. Again, the metrics that you care about might not be the same as somebody else. Your company or your deployment deployment might specifically need accuracy a lot more than they care about how latent or how long it takes the language model to generate a response, so the implementations will vary case by case. So I've talked about LLM ops a lot and why LLM ops is important. So a lot of the issue with current evaluation frameworks is that, again, they're just DevOps frameworks that are pushed into the LLM space. What that means is they don't control for these very specific metrics that you want to evaluate in large language models. Things like answer correctness, context recall, and other things like, oh, can we trace the actual LLM back to or can we trace like the LLM or maybe the augmented system to the data that it's generating this response from to make sure that it's not doing things like hallucinating up false responses, right? So that's the problem with a lot of these current evaluation frameworks out there. So what I'm advocating for is when you're out there building an LLM, whenever you create a new LLM framework for your organization, you ought to prioritize observability. A key issue on why LLM observability is so not great right now is because developers and researchers alike are just running forward with developing the next more powerful LLM, getting the next bigger amount of GPUs, and getting the next more accurate LLM. Post any of that, without any actual evaluation frameworks or observability frameworks, we're not able to have a great vision on how we can see how the LLM is performing, if it's being transparent, if it's being secure, if it's being accurate, and if it's being efficient. So some key takeaways from today's presentation is that first off, generative AI observability is really important when we're deploying a generative AI system. In fact, I would argue that observability is probably the most important aspect of a system because it's able to tell you how the system is performing, not just the fact that you have a chatbot, but you know your chatbot is effective. Second, I've introduced some key metrics for monitoring. That's things like how we can measure the latency, the accuracy, and the efficiency. Then I've talked about some advanced tools for real-time monitoring, but my greatest suggestion is that when you build your own LLM ops framework, prioritize observability. Use some of the libraries software that I've recommended, and don't go to a third-party vendor. If you can build your own specific to your use case, that's going to be where the money's really at. Thank you. My LinkedIn is Richard Shan. You can find me there, and my email is on this slide. I hope you have a great rest of the conference.
So I'm pretty sure Richard's going to have a great career, but if he doesn't make it as a tech guy, he could be an auctioneer, because that man just put out an hour's worth of text in 5 minutes. So good job, Richard. All right, now we're going to Sophia. Sophia is going to talk about something that's really important and we probably didn't talk about enough. Can you grab my glasses? Yes, I'm blind as a bat without these things. So we're going to talk about responsible and explainable AI.
Just responsible.
Just
we only have 5 minutes.
We only have 5 minutes. If we had 10, we would get explainable, but because we have 5, we are going to just go for responsible, which is good. So big buttons forward, little button below it is back.
All right. Thank you. All right. Good afternoon, everyone. My name is Sophia Rowland, and I'm a product manager at SAS. And as promised, I'm here to talk about responsible AI considerations for language models. But first, why care? AI usage is all around us, and that's not going to change anytime soon. I absolutely love this example. It was an AI-generated image used to market an event last year in Scotland, and from this example, we can really start to see how far generative AI has come, or how much better we're getting at proofreading things before we start to post them. Because attendees to this event were promised cat-gatting, and karchi tuns. But alas, there was no cat-gatting to be found. The event looked nothing like this beautiful poster, and people went on to laugh it off after getting their refund. Now here's a refund that's slightly harder to laugh off. A court in Canada had ruled that an airline must provide a refund to a customer who asked their chatbot if they were due one. The chatbot said yes. And the airline said, no, that's not consistent with our policies. The court said, actually, the chatbot lied. You have to get a refund. So who knew that an incorrect chatbot response was going to be worth $812.02? But it's not just financial costs we need to worry about. There are reputational risks at hand as well. I know a lot of folks are using language models to write their emails for them, but again, make sure you proofread. A local college I had sent an email showing support about a local shooting, and in the email, it actually cited that the email was generated by ChatGPT, which came across as very disingenuous. I mentioned this not to dissuade you from building AI systems, but rather to inform you of these potential pitfalls so that you can be better prepared. I like to hike, so I like to think of this as like a hike. Views may be lovely, your AI system may be lovely, but you want to make sure you review the weather conditions, you understand the trail ahead, you know how strenuous that hike could be, and you pack the appropriate materials. So let's review that trail ahead so that we can be better prepared. All right, in our few minutes together, let's just briefly go over 7 things that you can be doing to build AI systems around language models more responsibly. First, we need a clear understanding of what we want to build. We need to understand its consequences, the purpose, how it should be used, any limitations, and what is at risk when it gets a wrong answer, because it will be wrong. We want to sanitize the inputs that the user provides. We don't want to just take what the user chats in a box and sends it directly to the language model. We want to make sure that, depending on our use case, there's no confidential information we're sending to that language model, including personally identifiable information or intellectual property. We also want to be on the lookout for prompt injection, where a user will try to override the instructions that you've provided to the language model for malicious purposes. Now, traditional text analytics can help you prepare these inputs for your language model, but you need to make sure you select the right model for your use case. You need to think about where that model will be running. Is it on your premise, behind your firewall, or is it in a public cloud provider? You need to think about the languages that model needs to support. Maybe you need to support multiple models because you need to support multiple languages. You need to think about the size of that model. Can you afford a very large model at all times? What about a smaller one? And of course, you need to think about how generalizable and how specific your use case can be when selecting the right language model. You can add context to that language model using a process called retrieval augmented generation. I'm trusting everyone is now an expert after today. Yes? Perfect. Of course, like, you don't want to send your inputs from the user straight to the language model. You don't want to send what your language model returns straight to the user. You can look for things through evaluations like, was this answer relevant to what they were asking? Was this a toxic response? And again, you can use things like evaluation frameworks here, or you can use traditional text analytics to start to glean some of this information out. Red teaming. So I believe that breaking things can be a lot of fun. And red teaming is the process of trying to act like a malicious user to try to break your system. You try to get a toxic response. You try to get inaccurate data. You try to get data that might be confidential, that you don't want coming outside of your organization. Again, by finding these problems, you can start to begin building around them to build a more secure system. But reminder, the language model will get it wrong, and you need to prepare for that case. This can be as simple as a report a problem in a chatbot, just so that your user can provide the correct information, let you know that something's gone awry, so again, you can fix the problems as you are aware of them. Now, I see people taking photos, but don't worry, you don't have to take photos of this slide. I have a lot more information here in this blog, including that beautiful slide that I didn't build. But if you do take anything away from this session, it's that language models, like all AI systems, have inherent risks, but if we understand those risks, we can design our AI system to mitigate those risks. If you don't get the QR code, you can always reach out to me on LinkedIn, and I'm happy to share these materials as well. Thank you, everyone.
All right. We have one final speaker. We have Ms. Angela Jones. Angie, sorry. I'm very sorry. Of Codename Goose, an open source local AI agent. So come on up. All right. Black button forward.
All right.
All right. Good.
Hello, everyone. I want you to meet Goose. So Goose is an AI agent that works right on your machine. It's ready to handle development tasks out of the box from writing and debugging code to setting up development environments. And there's been a lot of talk about AI agents over the last few months, and that's because we believe this is where we'll really start to see value out of AI. So, what are AI agents exactly? When you interact with chatbots like ChatGPT, for example, you can ask it how to do something, right? And it'll give you step-by-step instructions. For example, if I ran into an error while coding, I could paste that error into ChatGPT and ask it to help me debug. But because ChatGPT doesn't have access to my code base, it's going to speculate about the cause of my error, and it's going to give me a couple of possible solutions to try. And then I'm going to manually try. Wait, we went too far. Did we? No. Okay. And then I'm going to manually try the solutions that they've given me. So I'm taking it, okay, I'm going to try this, all right. And if that doesn't work, I'm going to come and paste what happened in there. And we're going to do this over and over until we figure it out or I just give up. So AI agents greatly simplify this flow by talking with the LLM on my behalf. Okay, this PowerPoint, so I don't know how to make this play. Let me see. No. How I make the videos play?
I think, can you?
Don't get stressed, okay?
I won't get
All right.
I
Wait, let
think
me
if we
see.
double click like that,
Oh, I'm not on the internet either. Okay, don't worry about it.
are you sure?
Yeah.
We can get you there.
No, I'm just
Okay.
gonna go with it.
All right,
Y'all
we
with
go
me,
with
right? So envision this like actually running. But I can basically, this is Goose on the right, and then on the left is the IDE, right? And so I can say, hey, Goose, can you fix my error? And then Goose will, I don't have to explain like what's going on. It just kind of knows because it's connected to my system. So in this case, my IDE. And it can see why the error is occurring. And instead of telling me how to fix it, it's just going to fix it on my behalf, and it'll let me know what it did to do that. All right?
Click on that. There you go. Now hit play.
Okay. So how does all of this work exactly? Well, the agent sits between the user and the LLM. So Goose allows you to connect with the LLM of your choice, right? So it's not a closed system. That could be models from OpenAI, from Anthropic, from Google, or even local open source models from Olama. So the LLM provides cognitive abilities to the AI agents, and most AI agents, like Goose, will have this chat interface themselves. You type in your prompt, and then the agent will send your prompt to the LLM. At the same time, the agent will also inform the LLM of what it has access to. So let's look at what was happening under the covers when I asked Goose to fix my null pointer exception. So I typed my request into Goose's chat interface, and then Goose sent my prompt to my chosen LLM, and also let the LLM know what it has, what tools it has. So tools. Tools are one of the most important aspects of agentic AI, because this is what, oh, I didn't see all y'all up there, child. Tools are what enable the agent to interact with external APIs and execute actions. So the tools themselves are essentially functions that interface with API endpoints. And in the example that I didn't show you, but you saw, I added a JetBrains extension to Goose, and with that, Goose now has tools for interacting with code within a JetBrains IDE. So Goose is not limited to one IDE. It could work in VS Code and any of the JetBrains extensions or any other code editor. JetBrains developed these tools themselves to enable agents to work with them. So here, Goose is saying, the user is requesting that I fix a null pointer exception in the user service.java file, and I have tools to read files, to analyze code, to edit files, and to run tests. So it's letting the LLM know what it needs to do and then what tools it has at its disposal. So the LLM is going to analyze that request and then select the appropriate tool from the list. So the LLM is saying, oh, you can read the file? That would be super helpful. Do that and then provide me with the results. And so Goose will then send the file as a resource. The agent then executes read file and sends the output back to the LLM. The LLM recognizes the issue, which is that the DB variable is not initialized, and now it selects another tool, the edit file, to fix the issue. And notice it's saying, okay, in this particular file, I want you to go to this line number and replace the text that's there with this new text. The agent executes edit file to fix the user service.java. It outputs what it's doing to the user. It also is going to inform the LLM, and then the LLM determines, okay, this will be a good time to probably run the test to confirm the change. So it tells the agent to execute the run test tool. And the agent does so and then passes the results back to the LLM, who then tells the agent what to tell the user. So this is where you get your, okay, everything's done, anything else you want me to do type of message. Now that was just the use of one extension, but there's almost 2,000 extensions, and this list is growing on a daily basis. You can add any of these extensions to Goose, and it'll know how to use it thanks to an open standard called the Model Context Protocol, also known as MCP. Any MCP folks in the room? Hey, my tribe. Okay, so with this protocol, anyone can make an MCP server that exposes APIs or data through tools. And you can add any of these MCP servers to Goose as extensions. So say, for example, that I added extensions for a dev tool, a drive system, and a data system. So my agent can now do some pretty interesting things that would otherwise be tedious for me to do manually. For example, I can say, hey, Goose, can you maybe create a quarterly revenue report based on info that's in my database, include references to previous financial analysis docs from my Google Drive, and then write a report and save it to my file system, right? I could do something like say, hey, can you update my API to handle this new field that's in the database and follow the best practices that's in my outline in my Google Drive. And Goose is gonna switch between these extensions to complete that task end to end. Out of the box, Goose comes with, oh, look, the video's playing. Look at us. Yes. All right, so out of the box, Goose comes with a developer extension, and it includes tools for things like editing, taking screenshots, running shell commands, very helpful. So before adding any extensions at all, you could use Goose to like organize your messy desktop, for example. The GitHub extension, this one is one of my personal favorites. So not only can you get Goose to write code for you, but you can also have it do things like create a repo, make a pull request on your behalf. For this one, I needed to add a GitHub API key, and I limited Goose's access to only a few repositories. Goose can even turn ideas into code. So using the Figma extension, you can ask Goose to take a design, which is on the left, and then within a few minutes, it'll actually build out the app, which is on the right. Goose is available as both a desktop app as well as a CLI. Here, I've added an extension for Google Maps, which requires an API key. And in this session, I'm asking Goose to help me get around Mardi Gras traffic in New Orleans. In case you haven't heard from my accent, that's where I'm from. Notice Goose here is using two extensions to help me. The Fetch to scrape the parade schedule and route, and then Google Maps to get location and determine if it's on the route. And I love the ability to like mix and match the extensions to accomplish pretty much anything I want to do. On the Goose website, we have a few MCP servers listed as extensions, some that we've built ourselves, such as the developer extension, that's the one I showed you about running the shell commands and things, computer controller, which can run like Apple scripts, do pretty neat stuff, it could browse the web, and then memory, which can hold like data that I want to persist across multiple sessions. And then there's some community ones listed here as well. And like I mentioned, anyone can create an MCP server. There's even MCP SDKs in Python, TypeScript, Java, and Kotlin if you want to turn your favorite API into an MCP server. So there's quite a few directories out there listing. Right now there's about 1,700 probably today, MCP servers. But heads up, the quality of them could vary because, like I said, anyone can create them, so not all of them were created by the vendors themselves. As for the LLMs, like I said, you can bring your own LLM, whatever LLM you want to use, but you want to make sure that it supports tool calling because remember, that's how the agents execute tasks. So there's a couple of leaderboards out there comparing models specifically for use with agents. One is the Berkeley Function Calling Leaderboard, and the other is Galileo. Personally, I found that Claude Sonnet's tool calling capabilities are the most effective right now for operating Goose extensions. But as we all know, the LLM landscape is quickly evolving. So we're so encouraged. Goose was trending as #1 on GitHub for a while. There's an article in Forbes today about it. So there's a lot of great reception. We're so encouraged about it. And we invite the AI community to build with us. So it's all open source. Anything that you want to see, you can build it or just kind of open an issue, and we'll tend to that as well. But I think together we can achieve a level of innovation that no closed system can match. Thank you.